Okay, we have seen 3 cases. This is, by the way, this is my abbreviated rules for vertical and horizontal asymptotes. We're going to have another rule for another kind of asymptote, and that is, sometimes it's called the oblique asymptote, but we usually say the slant asymptote.
What?
Slant asymptote.
Are you putting the other ones?
Because I have a new rule. So my new rule is we've had rules for when n is less than m gives us this horizontal asymptote. When n is greater than m, we have this. We have no horizontal asymptote. And when n equals m, we have the ratio of the leading coefficients. So we have we can find a new kind of asymptote in the case that n is 1 bigger than m. Exactly 1 bigger than m. This gives us a slant asymptote, and then on your notes you can just write long division
No.
to find it. Long division to find it.
I forgot how to do long division.
And so do you see that which one this is a special case of which case here?
N is bigger than m.
N is bigger than n. So this is not a contradiction. This is also true. There is no horizontal asymptote and when n is bigger than m, and when n is bigger than m by just 1, then you get a slant asymptote. So let's look at a couple of examples to see what that looks like. I hope you remember how to do long division, because we're gonna do it.
Wait, can we do like the synthesis one instead?
Sorry.
Can we do the other?
Well, let me show you using long division, and then you can formulate that into whether you want to try
Okay, so no.
synthetic division. So there's a reason why we're going to do long division, is because we're going to get we're going to ignore the remainder, just as a spoiler alert. So just so you know, we're going to be ignoring the remainder. So here's an example. So let's start with the 2 that we've been doing so far, and then we will add slant at the end. So let's look for vert.
-1. X equals -1.
So how did you find the vert?
Just 0.
It's zeros of what?
X.
Huh?
Denominator.
Of the denominator. You could call it d of x. So we want x plus 1, which is our denominator, to be equal to 1. Solve it. X equals 1. That's the vert asymptote.
-1.
-1, thank you.
Yeah.
Okay, so hor is next.
1.
None.
Or
Tell me how to do it. Walk me through.
zeros of the numerator.
It's never zeros of the numerator. The zero, if you want the zeros of the function, if you say find zeros of f of x, that's setting the whole thing equal to 0. And then you multiply both sides by x plus 1, cancels over here. Anything times 0 is 0, so you just get the zeros of the numerator. So that's finding the zeros of the function in general. It is finding the zeros of the numerator. That's not on our list of, that's a good skill to have, and it's a good thing to know, but it's not on our list of finding asymptotes. How do I find, Annabelle, how do I find the horizontal asymptotes? What's my procedure?
You pull out, you have to find, see how it says horizontal if n is bigger than n? Then you have to pull out everything, so you take your whole f of x, right? So that's like your n of x and then d over x that it says is there, right? And then you pull out your, where the, what's it called, the exponent is 2, so that's, what's it called, an is larger, so the n is bigger than the n.
Which one is n and which one is m?
X to the second, or x to the second power.
So our horizontal rules require us to compare n and m.
And since n is bigger than m,
So we need to write down what n and m are first. What are
So
n and m?
equals 2,
N equals 2 comes from here,
and then m equals 1.
and then m equals 1 because this is an implied power of 1. And so how does n compare to m?
N is bigger than m, so now you know that there's no horizontal class.
So there's none. So for horizontal, we just write none. Okay, and now we have a new asymptote to check for. So for slant asymptote, go ahead.
Okay, so for slant, this is the one we just went over, right?
Yeah.
So since n equals m plus 1, you have to also do the same thing. So f of x, take that whole thing, then you do it to n, what's it called? N equals so 2, and then it's going to equal, because 2 is x to the second power, right? So you put 2 is your n, so n equals n. Or n equals 2.
N equals 2,
So then you have 2.
and m equals
and
1.
N equals 1, so 1 plus 1 equals 2 is correct.
Right. So that way we know that there's a slant asymptote because n is greater than m by exactly 1.
So now we can solve using long division. So you
Long
use
division. How do I do long division?
So you put in the little house thingy.
Yep.
You put x squared minus x.
X squared minus x.
And then outside you would do x plus 1.
X plus 1 in long division.
So then how many times does x go into x squared? It goes into it, what's it called, 2 times? So
No.
x.
I look at the first term divided by the first term.
So it would go,
X squared.
2 times x.
Okay.
I don't mean it like 2
Okay,
times.
gotcha. Right. So it's x, and then
X, and then once you get x squared minus x squared.
x squared plus x. Subtract them. I get minus 2x.
And then you do, what's it called? X times 2, so x times 2.
No, I look at the first terms.
Well, okay, x minus 2.
All right, minus 2, and then I do minus 2x plus
Which
1.
actually means plus, so that it cancels it out, so then you get your plus 1. And then you have to do times 1 again, right? Times negative 1, sorry.
Right. So this actually is my answer, and I don't care about the remainder.
Oh, yeah, I just wrong.
So I don't care about the remainder, so that actually becomes my y equals x minus 2, and I'm dropping the remainder. And that's my equation, and we'll graph it next time.